بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. السلام عليكم ورحمة الله وبركاته. Today inshallah we are going to discuss chapter 3 that is titled Guidelines, Principles and Theories of Designing the User Interface, of course. We will start with a brief introduction about these concepts. Then we will move to guidelines, principles, and theories in details. In the introduction, the broad difference or differences between guidelines, principles, and theories are the fact that the guidelines usually are low level, principles middle level, and theories high or abstract level. Generally, user interface designers have accumulated a wealth of experience, and researchers have produced a growing body of empirical evidence and theories, all of which can be organized under one of these three categories: guidelines, principles, and theories. Okay, first, the guidelines, as we said, they are low level. Usually they focus on the advice about good practices and cautions against dangers. So they are like advices: do, don't do. Okay, whereas the principles, they are mid-level in between the guidelines and theories. They are strategies or rules to analyze and compare design alternatives. If you are going to design an interface for a system, either software or hardware machine, you can apply or use or utilize these principles to compare between different design alternatives if you have an, different alternatives, in order to select one of them and go ahead. The theories, they are high level, they are widely applicable frameworks to draw on during design and evaluation, as well as the support or to support communication and teaching. Theories usually are predictive, such as those for pointing times by individuals or posting rates for community discussions. In many contemporary systems, designers have a grand opportunity to improve the user interface by applying established guidelines to clean up cluttered displays, inconsistent layouts, for example, and unnecessary text. The sources of duplicating stress and frustration can lead to poorer performance, minor slips, and serious errors. All may cause user dissatisfaction and abandonment of your system completely. So guidelines in general, the guidelines, principles, and theories, they offer preventive curement or medicine and remedies for these problems. in order to satisfy the users and thus retain their usage. We need to retain them. We need to have a high rate of retention for our systems. So let's start with the details of guidelines. Guidelines usually, as we said, they are low level, so they are like shared language between the designers, the HCI practitioners, and the end users to promote consistency among multiple designers in terminology usage, appearance, and action sequences. It is The guidelines are usually derived based on best practices, practical experience. So the best practices for a specific type of an interface or a software or a machine that it is supposed to follow these guidelines 1, 2, 3, 4, 5. So the designers of that system should take these guidelines into consideration. As you can imagine that the guidelines unfortunately are too specific, this will lead them to be either incomplete or even harder to apply, and sometimes wrong, that they are not appropriate or applicable to specific types of interfaces. Might be applicable for interface A or system A, but for system B is not applicable. So it is difficult to generalize it. On the other hand, the advantages of it that the supporters or advocates of the guidelines are using to justify the importance of guidelines is building on that it is built on experience from design leaders who contributes to steady improvements. So not anyone can put a guideline, but the well-known guidelines, the famous guidelines, usually are created and proposed by design leaders that have spent plenty of time, years, in evaluating, designing interfaces and improve them through the time. This is an example for a guidelines of a smartwatch, for example, that Apple and Microsoft proposed and applied even to their smartwatches. You can see that some of them are related to the pickers, some of them are related to labels, to images, buttons, switches, sliders, and so on. Different styles we have here, for example, list style, stack style, sequence style. If you are going to go with list style, so you can or you have to apply the guidelines that are related to list style under switches, sliders, maps, and so on. Let's talk about some of them, that like the main blocks of them, of the guidelines. We have navigating the interface, we have organizing the display, third one getting the user's attention, and the fourth one facilitating data entry. So we have navigation, organization, user's attention, and data entry. The first one, navigation, or navigating the interface. We have a sample here that you can visit on this link, www.usability.gov, in order to see different guidelines in relation to navigating the interface. For example, with regard to standardizing the task sequences. So we allow users to perform tasks in the same sequence and manner across similar conditions. By the way, you will find during this course that one of the major goals of human-computer interactions in general is consistency. Consistency is very important in all aspects, on coloring, on size, on fonts, locations, navigations, data entries. For a specific system, all parts and layers of that system should be consistent in all matters. Okay, so here we need to put the tasks in a standardized sequence with similar or even same conditions. We need to ensure that the embedded links are descriptive. So if we are put a link that is a hyperlink that will lead us to another file or another page or another website, that link should be descriptive or self-descriptive by itself. The link text should accurately describe the link's destination. It shouldn't be a vague one like you can see in some places or some websites, some systems. Please click here. Okay, so if I clicked here, where this link will take me? Okay, use unique and descriptive headings. Use headings that are distinct from one another and conceptually related to the content they describe. Use checkboxes for binary choices. If we have a multiple choice, if it is a survey for example, or if it is any other choices, if there is a possibility for the response of that question or that section to be multiple, there should be a use of checkboxes. On the other hand, if it is one selection, one choice, one option, the use of radio buttons should be used. That is, just one selection is allowed. So from the appearance, if it is for the checkboxes, for example, it is usually square. And for radio buttons, they are circles. Okay, so it should be clear for me, even if it is not written, that this is multiple choice or only one selection is allowed. From the appearance, I can know whether this is multiple choice or one choice. Okay, Develop pages that will print properly, i.e. in proper width and length even. If usually that system will be used in an environment where they have like personal official printers that will print on A4 or letter size papers. So if anyone will need to print, it should be by default printed into A4 or letter, not going straight to A5 or A3 or 2 even. Okay, the thumbnail images are needed to preview larger images like Google Images, for example. There should not be only a display for images with just vague titles or with dates or random numbers or letters. If they are displayed with thumbnails like a miniature image of the real image, it will be nice, it will be uh, easier for the user to navigate. He doesn't need to open this image and then realize that this is not the one that he would like to go through and then close it and find another one. The sample, or there should be a sample of accessibility guidelines. Accessibility guidelines for those with special needs. If we have, for example, text alternatives, so provide text equivalent for everyone, for every non-text content. So it can be changed to different forms, such as large print and braille speech. We have to consider the people with special needs, that there is a possibility for them to use this system, so that we have to have the ability to have it in a larger text. If that guy has like a problem with his sight, he's able to see but not clearly. The normal font size is not enough for him to see. And even for blind people, they need to have a braille speech, either to touch it or even for like the feature to out loudly read the contents of that interface. Okay, so this is regarding the accessibility. Time-based media, for any time-based multimedia presentation, movies or animation, there should be a caption or auditory description for those who are deaf, for example, or who have uh, hearing problems, or who have no knowledge about the main language. We can have a translation caption for them. It has to have the ability to be distinguishable, make it easier for user to see and hear contents, including separating foreground from background, right? Like coloring. Color is not the only visual means of conveying information. It has to be predictable, make web pages appear and operate in predictable ways, like the title each frame to facilitate identification and navigation. In other words, that it hasn't to be messy. So this is about the navigation of the interface. What about the organization of the interface or of the display? As you can see here that there are 5 high-level goals to organize the display. They are proposed by Smith and Mosier in 1986. What are they? Again, as you can see here, the consistency of data display. You will see it more and more during this course. First one, consistency of data display. Other one, efficient information assimilation by the user. Third one is the minimal memory load on the user. Fourth one, compatibility of data display with data entry. And the last, fifth one, flexibility for user control of data display. Use your common sense. From the title you can understand what does it mean, but try to link it to the topic. Consistency of data display. So during the design process, the terminology, abbreviations, formats, colors, capitalization, and so on, all should be standardized and controlled. They have to follow the same theme, same formatting, with some variations, of course, based on the attention required or the emphasis required, as we will see on the following point, inshallah. The second one, efficient information assimilation by the user. So the format should be familiar to the operator and should be related to the tasks required to be performed. For example, neat columns of data, left justification for alphanumeric data, proper spacing, and use of comprehensible labels. For example, if I would like to put an icon that will open a file, I am supposed, I am expected to put that icon as a folder or a file that is opening. Okay, for exit, for example, we can put like a door and an arrow to pointing to that door, like an exit, for example, and so on. Minimal memory load on the user. The user should not be required to remember information from one screen to use on another screen. A few actions minimize the chance for or of forgetting to perform a step. Labels and common formats should be provided for novice, for beginners, and intermediate users. So if the user, for example, pressed the next and went to a next interface or next page of that system, we shouldn't ask him about any specific information that was already shown on the first display that are unrelated to him. Okay. The fourth one, compatibility of data display with data entry. Compatibility. Compatible means that it is appropriate to that one. It is proper to it. It works with it. It is in line with it. So the format of displayed information should be linked clearly to the format of data entry. For example, if the data entry is name, birthday, email, display information has to be in the same format. Name, birthday, and email. Flexibility for user control of data display. Users should be able to get information from the display itself, by itself, in a most convenient way to do their tasks. For example, the order of columns and sorting of rows should be easily changeable by the users. Plasticity, flexibility are very crucial in human-computer interaction. The third one that we just mentioned while talking about the consistency here of the display is getting the user's attention. We said in the last slide that consistency is crucial. We should seek consistency in all aspects of the design process, but we made an exception that the consistency can be not followed sometimes for the sake of getting the user's attention if and when needed. These guidelines detail several techniques for getting the user's attention. And also these exceptions that we said from consistency should be consistent as well. That's why there are guidelines for them. So if we would like to get the user's attention for a specific form or specific link or specific button, for example, we can vary the intensity, marking, size, fonts, blinking, the color, and the audio. Regard to intensity, we can use two levels only, dim or bright, bold or light, for example, with limited use of high intensity to draw attention. As you can see here, for example, this is bold and this is not bold, this is light. Okay, marking. Underline the item, enclose it in a box, or point to it with an arrow, like what I am doing here, or use an indicator such as an asterisk, bullet points, dashes, signs, and so on. See that these are underlined because they are the titles of these guidelines. We are using here dashes to distinguish them, to get your attention to them. Okay, the size, use up to 4 sizes, maximum 4 sizes, with larger sizes attracting more attention. See that here in this we have 4 sizes in this slide. Have this size with different color, as we will see about coloring here. the other size, font size here, and the third one, and the very tiny one that is related to the copyright of this book and its supporting online material. Okay, the fonts, we can use different fonts if we think that will aid us to get the user's attention, but be wary, be cautious that while you are aiming to get the user's attention, avoid raise or getting the user distracted. Don't distract the user. Okay, blinking, we can use some features for a very important thing to be blink with a specific color or light. Okay, but it shouldn't be like very fast. It has to be in between 2 and 4 hertz. The coloring goes up to 4 standard colors as well, same as the font, the size, sorry, font only 3, but the size and the color shouldn't exceed 4, with maybe additional colors reserved for very occasional rare use. The audio, we can use soft tones of regular positive feedback, but harsh sounds for rare emergency conditions to not to distract the users. Okay, and by the way, you may ask or you may have heard from students of previous semesters that I care much about the correct concepts, not the memorization of information here. So in exams, don't worry about stating exactly the same wording if we have an open-end questions. Try to understand them and then you can explain them on your own words. In the same hand with getting the user's attention, as we said that we have to be cautious from getting the user distracted by the things that we are using to get his or her attention. So we have to be cautious about these guidelines, that there is a danger, there is a risk of creating cluttered displays by overusing these techniques. So don't overuse them. Don't on the same slide or on the same interface, don't use all for different font size, all don't use all of them 3 different font types. Don't use blinking, underlying, bullets, dashes. Don't use everything in the same interface. So we have to be consistent. If we use or we follow, for example, as we do here, the 2 coloring in the slides, just red and black, and you have 3 different font size. So we have to try our best to be consistent in all the slides, unless there is a clear need to change this scheme or theme. Okay, we need to consider that the Novice users, beginners, need simple, logically organized, and well-labeled displays that guide their actions. Whereas, on the other hand, expert users prefer limited labels on fields so data values are easier to extract. Thus, display format must be tested with users for comprehensibility. Okay, we need to test the interface whether it is comprehensive or not, it is comprehended, understandable or not, based on the end users. There are some systems or some interfaces that might be designed targeting only novices or targeting only experts, or sometimes targeting all sort of users with all level of skills and experience. So we need to hold the stick from the middle. We don't we need to design an interface that is guidable, that guides the novice users, but we don't want to post very much of the details on it, so we get the experts get bothered or bored by them. With regard to audio tones like clicks in keyboards or cell phones, ringtones can provide informative feedback about progress. When you press something, there is ring, there is ring, there is another one, another type of the ring if the button that I have just pressed, is risky or may lead to an irreversible action that I cannot reverse it. It is undoable. Okay, but we need to test them and evaluate their appropriateness. The fourth one, or fourth main point of the guidelines, is facilitating data entry. Again, Smith and Mosier, 1986, offer 5-level objectives for data entry. Here, with regard to organizing the display, they offered 5 high-level goals, but with regard to facilitating the data entry, they offered 5 high-level objectives for data entry. Consistency is the one first and utmost objective. Consistency of data entry transactions. Similar sequences of actions would speed learning. Second one, minimal input actions by user. Minimal input actions by users. Fewer input actions mean greater operator productivity and usually less chances of error. So we need to aim at asking the user to input data by itself or in writing format, to make it as minimal as we can, just for necessary things that cannot be done without letting or asking the user to enter. Why? Because The less the user will enter data, the less chances of error occur. Making a choice by a single mouse selection or finger pressing if it is touch screen is preferred over typing in a lengthy string of characters. To avoid, for example, misspelling or even different spelling in different accents or different types of the same language, even if it is the same language between American English and British English, for example, they have differentiations or differences in terms of spellings, for example, and so on. So selecting from a list of choices eliminates, reduces the need for memorization, structures the decision-making task, and eliminates the possibility of typographic errors. Okay, redundant data should be avoided. It is annoying for users to enter the same information in two locations, such as entering the billing address and shipping address when they are the same. There should be a way, for example, either to have one of them that is enough, or to have an option to or a checkbox to tick that is stating that the shipping address is the same as billing address. I have to have a choice or to provide the user with the choice. So duplicate entry is perceived as a waste of effort and an opportunity for errors. The third objective of data entry is minimal memory load on users. Users should not be required to remember lengthy lists of codes. Compatibility of data entry with data display. The format of data entry information should be linked closely to the format of displayed information, such as dashes and telephone numbers. If it is a Saudi mobile number, for example, without an international code, it is 10 dashes or 10 digits. So the space should be limited to then 10 digits, and it should be, for example, numbers only, not letters, not symbols, and so on, in order to minimize the errors. Flexibility of user control of data entry. Experienced users prefer to enter information in a sequence that they can control, such as selecting the color first or size first when clothes shopping. So the sequence here should be flexible enough based on the preference of the user. We must not force the user to select, for example, the size first, then the color. It should be either way, based on the user's preferences. Okay? Let's move to the principles. We have finished about some details of the guidelines. Now let's move to the principles. Principles, as we said, they are mid-level strategies or rules. They are aiding us to compare between alternative designs. So it is more fundamental, it is widely applicable and enduring than guidelines. As we said, that the guidelines are too detailed, too specific, and might not be applied on all designs. Okay, but the principles are wider, more generic a little bit, but sometimes in some areas they need more clarification. So we have fundamental principles here. We have the first one, the first principle here is to determine users' skill levels. Determines users' skill levels. Second one, identify the tasks. So we determine user skill levels, identify the tasks, choose an interaction styles, the 8 golden rules of interface design, prevent errors, and ensuring human control while increasing automation. Let's start with the first fundamental principle. Determine user skill levels. We have, as designers, we have to know the user with regard to their age, their genders, physical and cognitive abilities, education, cultural or ethnic background, training, motivation, goals, and personality. Okay, so the design goals here in this principle based on skill level. We have novice or first time users. We have knowledgeable, intermittent, or like intermediate, middle users, and expert, frequent users. This is based on their skills. With regard to their cultural or ethnic background, for example, if we are offering or designing the system for a conservative Muslim society or company, it is not appropriate, not it is not targeting or supporting the user satisfaction if we put the icons or the background, for example, of that system as a mini skirt girl or like a naked man or any or guy or anything that can contradict the principles of the culture of that society or of the the environment where that interface will be used. So designing for one class of users is relatively easy if we are just designing for novice or for experts. It is relatively kind of easy, but designing for several different classes with different levels of skills, it is much more difficult. When multiple user classes must be accommodated, the basic strategy is to permit a multi-layer, level structured or spiral approach or design. Like novices can be taught a minimal subset of objects, not and actions, not everything. They are not allowed to start using all features of the system from the beginning. But after gaining confidence from hands-on experience, users can choose to progress to greater level of tasks and interface concepts. For users with strong knowledge of the task and interface concepts, rapid progress is allowed. To permit users to personalize the menu contents based on their experience. based on their preferences and so on. To permit users to control the density of informative feedback that the user interface provides. Novices want more informative feedback to confirm their actions, whereas frequent users want less distracting feedback. As an example of feedback that the users may get, for example, when they click something to accept, for example, there might be a short message will be displayed in front of them that are you sure that you are accepting the terms and conditions, for example, or for example you are now accepting the terms and conditions. With regard to the second principle is to identify the tasks. After determining the user's skill levels, we identify the tasks. Task analysis usually involve long hours observing and interviewing users. You can just observe users while they are interacting with the interface that we have just designed or we have prototyped, or with the previous system that we are going to design a replacement interface for it. And even we can interview them to collect from them what tasks they need to observe, to do of the potential interface. So high-level task actions can be decomposed into multiple middle-level task actions and even to atomic actions. Relative task frequencies are important in shaping a menu tree. Frequent tasks should be near to the top and therefore quick to carry out. Rare tasks are deeper down. Relative frequency of use is one of the bases for making architectural design decisions. For example, in a text editor, like Microsoft Word, for example, frequent actions might be performed by pressing special keys, like the 4 arrows keys, insert and delete. Less frequent actions might be performed by pressing a single letter plus control, like underscore or bold or save, control S for saving, control C for copying, control V for pasting, and so on. Infrequent actions or complex action might require going through a sequence of menu selections, like changing the margins or revising default printers. It cannot be done with a shortcut. The third one, choosing an interaction style. After we determine the user's skill levels, we determine or identify the tasks, what is more frequent than others, what are the tasks, and so on. We have now to choose an interaction style. With different styles or interaction styles are there. For example, we have direct manipulation, navigation and menu selection, or form fill-in, or called fill in the blanks. Direct manipulation, again, try to use your common sense with those naming schemes with those titles to expect or to infer what do they mean. Direct manipulation, when designers can create a visual representation of the world of action. The user's tasks can be greatly simplified because direct manipulation of familiar objects is possible. Okay? By pointing at visual representation of objects and actions, users can carry out tasks rapidly and can observe the results immediately. Dragging and dropping an icon into a trash can, for example, it is one example of the direct manipulation. Okay? For, for the navigation and menu selection, users review choices, select the one most appropriate to their task, and observe the effect. So it is based on the menus, ribbons, and so on, tabs. Whereas in fill in the blanks, users see a display of related fields, move a cursor among the fields, and enter data where desired. We have common language being in control. Users learn the syntax and can often express complex possibilities rapidly without having to read distracting prompts. Natural language here, user interfaces respond properly to arbitrary spoken, like Siri, example, or Bixby in Android, or typed natural language statements, like web search phrases. As you can see that each one of these 5 interaction styles has its own advantages and disadvantages. Like direct manipulation allows easier retention, allows errors to be avoided, but with the condition that the user is expert and so on. But it is probably hard to program from the first place or at the first place. May require graphics, display, and pointing devices. Okay? Some devices or displays are not easy for them to be manipulated or to like using dragging and dropping without a mouse or without a touch screen. Menu selection, it shortens learning, reduces keystrokes, but it consumes screen space. It may slow frequent users. As the frequent user, you need to go through a menu to another menu to another menu to another menu to reach the task that he wants to perform. Form filling, it simplifies data entry, requires just modest or not heavy training, but it consumes screen space as well. And it is prone to errors. Command language, it is flexible, appeals to power users, expert users. So there is a poor error handling usually, and it requires substantial training and memorization of the commands. The natural language relieves burden of learning syntax. As while you are, if you have tried it, talking to Siri or Google Assistant or Bixby and others, it is easy for novice users, but it requires clarification dialog. Might not show context. Unpredictable. The system may hear something else than what the user really said. Okay, this is an example for each one of them. This is for the command line. This is fill in. This is pull down menus. And this is 2D menus here. We can use these as a way of input. Okay. The fourth principle, or the fundamental principles, the 8 golden rules of interaction design, of interface design, sorry. The 8 golden rules of interface design. Again, the first and utmost one is strive for consistency. Consistent sequence of actions, identical terminology, consistent color, layout, characterization, fonts, etc. Exceptions such as required confirmation of the delete command or no echoing of password should be comprehensible and limited in number. So as we said that there are some exceptions, like for the purpose of getting the user's attention, but there should be limited. They should be limited. The second one, second rule, second golden rule of interface design is seek universal usability. Universal usability. Recognize the needs of diverse users and design for flexibility, plasticity, facilitating transformation of content. We have to strive to accommodate all level, types, classes of users. Offer informative feedback. For every user action, there should be an interface feedback, either to confirm or to warn, and so on. For frequent and minor action, the response can be modest. For infrequent and major action, the response should be more substantial. Visual representation of the objects of interest provides a convenient environment for showing changes explicitly. The fourth golden rule is design dialogues to yield closure. Yield closure. Sequence of action. Informative feedback. And so on. There should be a clear sequence of dialogues till the end. Sequence of action, like process of buying a product online, should be organized into groups with a beginning, middle, and an end after paying, for example. Usually, the feedback for completion until the end, until the closure of the sequence of the action of the task, gives the users satisfaction of accomplishment. that it is clear to them that they have accomplished something, or they have accomplished what they wanted to do. Okay. The fifth golden rule is prevent errors. As much as possible, design the interface so that users cannot make serious errors. If users make an error, the interface should offer simple, constructive, and specific instructions for recovery, for reversing the action, for undoing the action. For example, users should not have to retype an entire name address form if they enter an invalid zip code, but rather should be guided to repair only the faulty part. Only in this example, they should only correct or ask to retype the zip code, not the entire address. The sixth golden rule permits easy reversal of action. As much as possible, actions should be reversible. Okay? So first we try to prevent errors, but if the errors occur, we have to allow the user to reverse his action, to undo an action. This feature relieves anxiety since users now know that error can be undone, and encourages exploration of unfamiliar options, thus learning the system more and increasing the level of satisfaction. The seventh golden rule is keep users in control. Experienced users strongly desire the sense that they are in charge of the interface and that the interface responds to their actions. If they would like to change the location of an icon, for example, or the sequence, or to personalize, in other words, the interface, it is recommended to allow them to do so, with specific limitations, of course. They do not want surprises or changes in familiar behavior. If you have one of the users is short or is left-handed, for example, so and he preferred to put the OK in the left or in the right based on his hands of using the mouse, so he is supposed to be allowed to do so. Reduce short-term memory load, the last golden rule of interface design. Humans' limited capacity for information processing in short-term memory requires that designers avoid interfaces in which users must remember information from one display and then use that information in another display. So the fifth principle here, prevent errors, we mentioned it as one of the 8 golden rules of user interface, and it is a principle here as well. One way to reduce the loss in productivity due to errors is to improve the error messages provided by the interface. Error messages should be specific, positive in tone, and constructive as well. Let's see these examples. Error. This is an example, error message. Another one, critical error. Do you want to close this window? Okay, so From these two examples, we can, or they can lead us to the this slide where it shows that the error messages should be clear, should be positive, and to the point. It shouldn't be like humiliating the user. It shouldn't be vague. The user cannot know from it what is the error. Okay, so here, for example, that the text of the error message should be clear. There should be a title here for the error message. What type of error that the user has made or is about to make. Okay, there should be an icon, informative text in relation to it, and it should be positive. It shouldn't be like, no, you did a mistake. So what is the mistake? What is it? Okay, how can I reverse it, and so on. So the most effective approach is to prevent the errors from occurring from the first place. Prevent them. Normal 1983 provides design techniques to reduce errors. One is called correct actions. Gray out inappropriate action or menu items so they cannot be selected. Selection rather than freestyle typing, like in calendar. Automatic completion of typing words, like auto completion. But the complete sequence, the other technique, design technique, is called complete sequences. There are single abstract commands, an action that requires several steps to reach completion. For example, in automobiles, drivers do not have to set two switches to signal a left turn. A single switch causes both front and rear turn signal lights on the left side of the car to flash. Likewise, when a pilot throws a switch to lower the landing gear, hundreds of mechanical steps and checks are involved automatically. So there is a sequence of commands or actions that is very simple for simple actions with low level of risk, and there is a complicated complex actions and sequence of actions that are needed for those risky actions or tasks. Okay, let's move to the sixth principle, which is ensuring human control while increasing automation. It is true that computer system designers have generally been increasing the degree of automation over time as procedures become more standardized and the pressure for productivity grows, and the plan for digital transformation is increasing, but there is, on the other hand, a need to ensure human control. It shouldn't be 100% automated out of human control. There are some aspects that uh, machine generally better in doing them, like we can see here in this column, but on humans in general still are better with some or a number of actions. Okay, so supervisory control needed to deal with the real world open system. Air traffic controllers, for example, with low frequency but high consequences of failure. Federal Aviation Administration (FAA) design should place the user in control and automate only to improve system performance without reducing human involvement. Okay? Now, let's move to the theories. One of the discipline of human-computer interaction is to go beyond the specifics of guidelines and build on the breadth, width of principles to develop tested, reliable, and broadly useful theories. Of course, for a topic as large as user interface design, many theories are needed. There are multiple theory types that researchers and designers consider when evaluating user interface. Some theories are descriptive, that are helpful in developing consistent terminology and useful taxonomies for objects and actions, thereby supporting collaborations and training. Okay, others or other theories are explanatory, describing sequences of events and, where possible, cause and effects, making interventions possible. For example, observing behavior, describing activity, conceiving of designs, comparing high-level concepts of two designs and training, etc. Still, other theories are prescriptive, giving designers clear guidance for their choices. Finally, the most precise theories are predictive, enabling designers to compare proposed designs for execution times, error rates, conversion rates, or trust levels. These theories can be grouped by a theory type, as they are here. This grouping or types based on their theory, descriptive, explanatory, perspective, and predictive. And on the other hand, they can be grouped by human capacity or skills, motor task, perceptual, and cognitive. The motor task or that are related to motor skills, let's say skill in pointing, clicking, dragging, or other movements. Perceptual that are related to visual, auditory, tactile, and other human sensory inputs. For example, predicting reading times for free text lists or formatted displays. The third one is the cognitive, that is related to problem solving with short and long term memory, like planning, the sequence of steps needed to pay a bill. So let's talk now about some types of theories. That are based on descriptive or explanatory. The first one here, design by levels theories. Then we will move to stages of actions theories, consistency theories, contextual theories, and dynamic theories. Without going into detail, we are going to mention them, but try to concentrate, please, so you don't get distracted and you don't get confused between them. Use your common sense. The design by levels theory. One approach to developing descriptive theories. So it is one of the descriptive theories that separate concepts according to levels. We can have like conceptual level, semantic level, syntactic level, and lexical level. Can start with high level design and move to smaller objects and actions. For example, decomposition from building into floors, floors into rooms, rooms into doors, walls, and windows, and so on. The stages of actions. Stages of actions is under explanatory theory that portray the stages of action that users go through in using interactive products such as information appliances, web interfaces, or mobile devices. It is worth mentioning here the Norman's 7 stages of action. Norman in 2013 offers 7 stages of action arranged in a cyclic pattern as an explanatory theory of human-computer interaction. It starts with forming the goal, then forming the intention, then specifying the action, then executing the action, then perceiving or understanding the system state, interpreting or explaining the system state, and finally evaluating the outcome. Then it can go back to the first stage cycle. So Norma's contributions here of these 7 stages can be explained or can be practiced on cycles of actions, from forming the goal throughout the evaluating the outcome. So it leads naturally to identification of gulf of execution and gulf of evaluation. The execution, the mismatch between the user's intention and the allowable actions. Here, the execution, how do I use the system? How does the user use the system? Okay, and then the gulf of evaluation, the mismatch between the system's representation and the system expectations. What's the current system state? This theory leads Norman to suggest 4 principles of good design. The theories, the 7 stages of action, of stages of action or explanatory action by Don Norman, leads him to suggest 4 principles of good design. The visibility, good perceptual model, good mapping, and feedback. First one, the visibility. The state and action alternatives should be visible. The user can tell the state, goal of the device or interface, and the alternative actions. It should be visible, clear to the user. A good conceptual model. There should be a good conceptual model with a consistent image of the system. The designer provides a good conceptual model for the user with consistency in terms of presentation of operations and results. Good mapping. The interface should include good mapping that reveal the relationships between the stages, the different stages. And finally, the feedback. The user should receive continuous feedback. So here, one of the benefits of these stages and principles in relation to them, this will lead us to try to avoid errors or failures. 4 critical points where user failures can occur. Users may form an inadequate goal from the beginning, users might not find the correct interface object because of an incomprehensible and understandable label or icon. Bad conceptual model. Users may not know how to specify or execute a desired action. Bad mapping. Or users may receive inappropriate or misleading feedback. Moving towards the third type of theories, that is consistency theory. An important goal for designers is a consistent user interface, as we keep repeating. The argument for consistency is that if terminology for objects and actions is orderly and describable by a few rules, users will be able to learn and retain them easily. The example below illustrates consistency and two kinds of inconsistency. A group illustrates lack of consistency, and B shows consistency except for a single violation. As you can see here, all of them are consistent in terms of the terminology. Delete insert character, delete insert word, delete insert line, delete insert paragraph. Here it is very messy. It is very inconsistent. Here we have delete insert, but here we have remove and bring, destroy, create, kill, birth. So there is a lack of consistency here. Whereas in B, there are some sort of consistency here. We have delete insert, delete insert, delete insert, except one single violation, remove insert. Why we didn't use the same terminology? This may lead to misunderstanding of the user. He may think that this means something else. Remove may mean something different than the delete, and so on. So the inconsistent action verbs in group A are all acceptable, but they are of different types. So we need to see consistency in all forms, in terms of coloring, naming, terminologies, icons, font size, and so on. Consistency is vital in giving users a clear understanding of the interface. The contextual theories these theories and design aspects might be called micro HCI. Micro HCI theories, or design by levels, stages of actions, and consistency. The first three types, design by levels theories, stages of action theories, consistency theories, can be called micro. The first three, these first three can be called micro HCI, micro human computer interaction theories, design by level design, stages of action, and consistency, because they address the specifics of how objects and actions appear on displays and what actions users take to carry out their tasks. Okay, because they cover measurable performance in terms of speed and errors. They are best studied with scientific methods of experimental and cognitive psychology using 30 to 120 minutes controlled experiments and statistical tests for significant differences between groups working on well-defined tasks. Okay, so these three theories that are or can be grouped as micro HCI theories best be tested with half an hour to 2 hours minutes experimental, controlled experimental and statistical tests that are come or carried out with well-defined tasks. Whereas the contextual and dynamic theories, the other two, the 4 and 5, can be grouped or can be called as macro HCI. Macro HCI thinking leads to different kinds of theories that might best be called contextual, since they consider the emotional, physical, and social contexts of use. So, for example, happy users will persevere in the face of frustration, cope with interruptions from neighbors, and ask for help when they need it. Whereas frustrated users will just or simply abandon the system. So macro HCI, the focus of them of contextual and dynamic, let's say, and let's talk first about contextual, focuses on case studies of user experience over weeks, not just 30 to 120 minutes, but here the user experience over weeks and months of user experience in realistic usage, not well-defined tasks. Here in real usage, without any restrictions usually, with rich social engagement. While micro HCI research is more about laboratory studies to collect clear performance measures for identifiable tasks, how many seconds to find the last flight on July 4 from Washington to London, for example, macro HCI research is more about ethnographic observation of users doing work or play in their familiar context over days, weeks, or even months. So the outcome, the usual outcome of micro HCI research are statistical significant differences that support or refute a hypothesis. So we have a hypothesis that for example, this design is better than the old interface in terms of the speed in locating the specific task needed and performing it, performing it by such seconds or minutes. Okay, at the end the hypothesis will be supported, will be accepted or refuted. Whereas macro HCI research, the contextual or dynamic one, are insights about what leads to increased user satisfaction. So it is not quantitative statistical like micro, but it is rather more related to qualitative satisfaction. How the context of use matters and how new applications can improve education's health, safety, and environment. So the environment here is key. Using a specific interface under specific environmental conditions may differ based on the environment conditions, either on hot, warm, cold weather, dry, humid, uh, day or night, and so on. Indoor or outdoor. The dynamic theories here, last one, that it is similar or under the same umbrella of the contextual as it is macro HCI. The key aspect of macro HCI is how users evolve over weeks and months, especially as they move from novices to experts, from new customers to frequent buyers, or from readers of Wikipedia to active collaborators or administrators. Will the user involvement with this interface of this system will change or improved or evolved during the time, the days, the weeks or months, or it will remain the same. For example here, that when dealing with long-term change in behavior for health, smoking cessation, diet or exercise or education, completing an online course or getting bored and abandoning it. Dynamic theories are strong among designers of online communities and user-generated content sites. They know that users often move through stages as they gain confidence and a greater sense of responsibility for quality. Okay, so we have come to the end of this chapter. Please try to review, answer with yourself and review the discussion questions at the end of each chapter. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.